This session we will be discussing factoring quadratics. And when we talk about a quadratic, generally speaking, we're talking about a trinomial that fits the following pattern. Okay, where A, B, and C are actually coefficients. So I think a better example of what that would look like. Okay, and understand this is an A, B, and C. A, B, and C. So again, a better example would be something that looks like this: 2x squared minus 11x plus 12, where C is the 12, B is the negative 11, and A is the 2. Okay, understand that A is not 2x squared. A is just a 2. The x squared represents the x squared. B is just negative 11. B is not negative 11x, it's just negative 11, and C is 12. Alright, so understand that A, B, and C are just coefficients. Okay, and C should always be a constant, thereby saying it does not have a variable attached to it. Okay, so again, we're looking in this session anyway, we're looking specifically at trinomials that fit the quadratic form. So some variable squared, variable singular, then a constant. Okay, alright, so let's look at our first example. Okay, now we've discussed factoring and how it's basically undoing multiplication. And when we're dealing with a quadratic, if we know it's factorable, then we're typically understanding that if I multiply two binomials, I should get the trinomial that I'm starting with. So if I multiply two binomials, a set of binomials times another binomial, I should get the trinomial that I'm starting with if I'm factoring. When we're talking about multiplying binomials, we introduced a method called F.O.I.L. First, outside, inside, last. Okay, well, in factoring a trinomial quadratic, basically what we're looking to do is FOIL in reverse. Okay, so basically reverse FOIL. Okay, so what we're looking at is, in the trinomial we have a first term. Okay, so this will be considered our first term in our trinomial and the problem that's given to us initially. So if that's our first term, then based upon our understanding of FOIL, then we know that the first times the first has to give us this first. Now if we're looking at this x squared, then we're saying, okay, an x times an x would give us an x squared. So first times first gives us first. Okay, so we have our first term in our two sets of binomials. So now we're going to focus on our last. Alright, the minus 36, the negative 36 is our last term. Okay, so now we're trying to figure out what in the last position of this binomial times what in the last position of that binomial will give us our last. Now when it comes to 36, you have options. You have 6 times 6, you have 36 times 1, you have what, 12 times 3, 9 times 4. What else do we have? 18 times 2. Okay, so we have a bunch of options, and the fact that the sign in second position is a negative sign lets me know that I'm going to have opposite signs in the middle for my binomial. Okay, so basically, to get this 5x, which comes from combining your outside and inside, the 5x here. We get it because the signs are opposite from each other. We're going to get it by subtracting our factors for 36. So if I'm trying to get to a 5, I look at what could be subtracted to get there. Okay, and so that leads me to use the 9 and the 4. Okay, so if I have a positive 9 and a negative 4, then that will get me to a 5x. Okay, so let's look. First times first gives me the first. Alright. Last times last gives me the last, because that's a positive 9 times a negative 4 gives me a negative 36. And you have to be real careful to make sure you have your signs right, because sometimes you'll get the right numbers, but it won't give you the right sign. So let's say if this was a plus 4, a positive 9 times a positive 4 would give me a 36, and it's very easy to just see that you got 36 and keep moving, not understanding that it needs to be a negative. So you have to make sure your signs are right. Okay, and then we say outside we get a negative 4x, and we say inside we get a positive 9x, and when we combine 9 and a negative 4, or in other words 9 minus 4, we get our positive 5x. Alright, so everything checks out. So because we've checked everything, we know we're on target. So this would be considered our answer. This would be considered the answer. So if we had x squared plus 5x minus 36 and we wanted to factor it, it would be the binomial of x plus 9 as one factor and the binomial of x minus 4 as another factor. So in other words, if I multiply this binomial times this binomial, I would get this trinomial that I started with. Okay. Let's look at another example. Let's try, let's see, 5x to the 5th minus 25x to the 4th minus 30x to the 3rd. Okay, now when I look at this trinomial, I see it doesn't necessarily fit my quadratic form, right? Because quadratic form is saying something squared, singular, and constant. Okay. But I realize that this trinomial can be factored by pulling out a GCF. If I notice my coefficients, 5, negative 25, negative 30, I can pull out a 5. Then if I look at my variables, I notice that x is present in each term. So the fact that x is present in each term, I can pull an x out, and I pull out an x to whatever the lowest exponent is present for the x. So x to the 3rd being the lowest exponent. Okay, so if I pull a 5x to the 3rd out of 5x to the 5th out of my first term, then that would just leave me x squared, because 5 divided by 5 would be a 1, and then x to the 5th divided by x to the 3rd would be like saying 5 minus 3, which is x squared. Right, my minus sign. Now I'm looking at my second term, my middle term, negative 25x to the 4th divided by 5x to the 3rd. So negative 25 divided by 5 gives me a negative 5. X to the 4th divided by x to the 3rd is like saying 4 minus 3, which is x to the 1st, which we just write as x. Write my minus sign. Now I have a negative 30 divided by 5, which is a 6. x to the third divided by x to the third. 3 minus 3 is 0, so that's like saying x to the 0, which is just 1, so we don't have to write an x, and we leave it as minus 6. So now you see, once we factor out the GCF of 5x to the third, excuse me, then we're left with a trinomial now that fits our quadratic form. Okay, so now what we want to do is set up our two binomials that would give us this trinomial. We're not focused on the GCF anymore. We've pulled that out. We're no longer looking at this. We're looking at a simplified version of this after pulling out 5x to the third, which is now just this trinomial right here. So the two binomials that we're trying to set up now are based simply on this trinomial right here, and I just bring down my GCF all the way down to the end. Okay, so I'm trying to find first, which is x squared, so first times first gives me first. And as far as the 6 goes, I know a 6 is a 6 times 1 and a 2 times 3. Well, since I'm trying to get to a negative 5, and the signs have to be opposite because this is a minus sign in the second position, so that tells me opposite signs. And so if I want to get to a minus 5, I know to use the minus 6 and the plus 1. So let's check. First times first is first. Last times last. 1 times a negative 6. 1 times a negative 6 is a negative 6. So last times last is last. Outside is a negative 6. Inside is a plus 1. So negative 6 plus 1 is a negative 5. Alright, so everything checks out. This is my answer. Okay, let's do one more. Alright, let's try 9x squared minus 42x plus 49. Okay, check to see if I can factor anything out. There is no common or GCF, common factor or GCF to be pulled out of this, so I just go ahead and set up my two binomials. Now what I do notice here is if I look at the first term, 9x squared, I notice that it's a perfect square because 9 is 3 times 3 and x squared is just x times x. And when I look at the last term, I notice it's a perfect square because 49 is 7 times 7. Alright, so as a helpful hint, anytime you're given a polynomial to factor and the first and last term of that polynomial are perfect squares, then typically you can factor using the square roots of those. Okay, that's typical. It's not always, but typically speaking, you can get by with factoring using the square roots. So if my 9x squared is my first term, then the square root of 9x squared would be 3x. So I write 3x in the first position for both binomials. So 3x times 3x is 9x squared. If 49 is my last term, then I can write a 7 and a 7 in last position. Now it has to be a positive 49, which tells me I have to either have both of these 7s as positive 7s, because a positive times a positive is a positive, or both of these 7s have to be negative 7, because a negative times a negative is a positive. But here's the thing, we need our middle term to be negative. So the fact that we need our middle term to be negative lets me know that I need both of these 7s as negative. Alright, so now I've finished. This is my answer, but I want to double check to see that it's right. So I look, first times first, it does give me the first. Last, negative 7, times last, negative 7, does give me the last, which is a positive 49. Then I do the outside, negative 21. Inside is a negative 21, or negative 21x, and outside negative 21x. If you combine a negative 21x on the inside with a negative 21x on the outside, you do end up with a negative 42x in the middle. Okay, so this would indeed be your answer. Okay, so that pretty much concludes factoring quadratics or trinomial quadratics using reverse FOIL method. As always, if there are any questions, please feel free to contact me in class or in my office. Thank you.